You know that feeling, right? Where you're drowning in information, maybe it's company data, maybe just the whole internet, and you know the answer you need is in there somewhere. But finding that exact piece of insight, or maybe you've got a really powerful tool, but you just wish it could do one specific thing perfectly for you. Well, today we're doing a deep dive into something in AI and machine learning that tackles exactly that. Fine-tuning your machine learning model. Think of it like taking this super smart, general-purpose AI brain and turning it into a specialist, an absolute expert in your world.
Yeah, it's incredibly relevant right now. We've got these huge pre-trained models, these foundation models everywhere. They know so much, generally speaking. Fine-tuning is really the bridge, between that massive general knowledge and getting something specifically useful out of it. So we're going to unpack what fine-tuning really is, and maybe more importantly, why it's becoming such a key technique for getting precise, actionable stuff from these models without, getting lost in all the complexity.
Right. So our mission today is to figure out how we adapt these big models for very specific jobs using our own data. Make them personal, make them useful for your unique needs. We'll get into the hows, the whys, and what it really means in practice. Okay, so let's break this down. When we talk about these machine learning models, especially the big foundation models everyone's talking about, they're like super smart generalists, right?
Exactly. They've learned from vast amounts of text and data. They can write, code, answer questions on almost anything. Brilliant generalists.
But what if you need a specialist? Like someone who doesn't just know about medical terms, but understands your specific clinical trial data, or knows your company's internal jargon. That's where fine-tuning comes in, I guess.
Precisely. That's the core idea. Fine-tuning is essentially tuning for a specific task. You take a copy of a pre-trained model, one that's already done its homework, so to speak, and you adapt it using your own data. It's about making it perform much, much better on one particular job that you care about. And the key action, the really fundamental part, is that fine-tuning actually changes the weights of that foundation model.
Changes the weights. Okay, what does that mean in practice?
The weights are like the model's internal connections, its learned parameters. Changing them means you're fundamentally altering how it processes information, how it makes connections, how it responds. You're deeply optimizing it, kind of rewiring it for your specific data and your goals.
Oh, okay. So it's not just layering information on top. It's changing the core thinking.
In a way, yes. It's adjusting that core logic to align better with the nuances and patterns in your specific data set.
Yeah.
And this is a really important distinction, actually. It's different from some other techniques you hear about. For instance, you hear about RAG, right? Retrieval-Augmented Generation. Well, RAG doesn't change the model's weights. RAG works by grabbing relevant information from outside, like a knowledge base, and feeding it to the model as context when it's generating a response.
Ah, okay. So RAG is like giving the model notes to refer to for a specific question.
Exactly. It's providing context on the fly. Fine-tuning, though, is more like sending the model back to school to specialize, actually changing its internal understanding based on new textbooks, your specific textbooks.
Got it. So we're not just adding a reference library, we're actually reshaping how the model approaches our problem, embedding that knowledge deeper.
Okay, so if we're talking about fundamentally reshaping the model, this deep specialization, what are the ingredients? What kind of data do we actually need? It can't just be any random stuff, right?
No, absolutely not. The data is critical and it needs care. Your training data must be in a specific format. You can't just point it at a messy folder. Often this means structuring it very carefully, maybe as prompt response pairs or in specific document layouts the model can learn from. Okay, specific formats. And where does this data live? Is there a standard place?
Practically speaking, yeah. Often it needs to be stored in S3. Amazon's object storage. It's just very common for these cloud-based ML workflows because it handles large-scale data well and integrates easily.
Right, S3. Makes sense. And what about the horsepower, the computing side? This sounds intensive.
It definitely can be. And that brings up provision throughput. This isn't your usual pay-as-you-go cloud computing. Provision throughput typically requires payment up front. Why? Because you're paying for allocated CPU, or more often these days, GPUs, the graphics processors.
Allocated, so dedicated machines just for my task.
Essentially, yes.
Yeah?
You're reserving a chunk of computing power to ensure you have consistent high performance. Fine-tuning can take time. It needs that stability. You don't want performance dips or interruptions when you're deep in the middle of retraining those weights.
So it's a commitment, both in terms of data prep and resources.
It is. And another important point, not all models can be fine-tuned. Yeah, some models, maybe due to their architecture or maybe they're proprietary, just aren't set up for it, or the creators haven't allowed it. So you always need to check the specific model's documentation first.
Okay, so Meticulous data prep, potentially significant upfront resource costs, and making sure your chosen model is even capable of being fine-tuned. It's definitely not a casual undertaking.
No, it's a serious process aimed at achieving a specific high-value outcome.
So, assuming we've got our perfectly formatted data ready, we've secured the necessary compute power. How do we actually do the training? How do we guide the model? Our sources mention a couple of different ways to approach this.
Right, there are two main strategies people use. The first is called instruction-based fine-tuning. This is very useful for adapting LLMs, large language models, to specific tasks. It usually involves some further training beyond the initial pre-training.
Instruction-based, so like giving it explicit directions.
Yeah, pretty much. It works by using labeled examples. These are typically structured as prompt-response pairs. You basically show the model exactly what you want it to do. For instance, for answering questions, you'd provide pairs like prompt. What's policy X? Completion. Policy X states ABC.
So you give it the question and the perfect answer.
Exactly. Or for following instructions, you'd give it an instruction and the expected response, like prompt. Summarize this report. Completion. This report covers points 1, 2, and 3. The model learns to mimic that input-output behavior.
Okay, that makes sense. And you mentioned subtypes.
Yeah, within that you have single-turn messaging. This is good for chatbots handling simple one-off questions. Think, what's my account balance? Or how do I reset my password? Each interaction is self-contained.
Got it. Quick Q&A.
Then there's multi-turn messaging. This is built for ongoing discussions. The model needs to remember the context of the conversation. Crucial for more complex support chats or anything that isn't just a single question and answer.
Right, so it remembers what we were just talking about. What's the other main approach then?
The second one is continued pre-training, which is also called domain adaptation. This is less about teaching specific tasks and more about adding some expertise in a broader subject area. Maybe you want to deeply understand all your internal AWS docs, for example.
Adding expertise. How does that work? Is it still prompt response?
No, and this is the key difference. Continued pre-training typically uses unlabeled data to continue foundation model training. You feed it a massive amount of text from your specific domain, like medical journals, legal documents, technical manuals, without necessarily structuring it as questions and answers.
Unlabeled data, so just raw text from the field.
Largely, yes.
Yeah.
The model learns the language, the concepts, the relationships within that domain by immersing itself in the text. It's good for industry-specific terminology, helping the model understand nuances like complex medical terms or the specific meaning of phrases within, say, the AWS documentation in context, not just defining them.
So instruction-based is like teaching specific skills with examples, while continued pre-training is like sending the model for a deep immersion course in a whole subject.
That's a great analogy. One is about specific behaviors. The other is about deep knowledge and understanding of a domain.
It really feels like these aren't just surface-level adjustments. You're fundamentally changing how the model operates within your specific world.
Right.
Okay, these methods sound powerful. Let's connect it back to the real world. Why would someone go through all this effort and expense? What are the actual use cases where fine-tuning really shines?
Oh, there are many compelling use cases for fine-tuning. For example, think about customer support. You could fine-tune a model by analyzing previous emails and historic messages from customer interaction.
So it learns from past conversations.
Exactly. It learns your specific customer issues, the language they use, the best ways to respond. It can make support much more efficient and empathetic. It's also great for automating categorization tasks with high accuracy. Sorting emails, tagging customer feedback, routing support tickets based on subtle content details a general model might miss.
I can see that. What else?
Building highly specialized chatbots. Not just generic ones, but bots that deeply understand your business, your products, your internal processes, your knowledge base, true domain experts. And also enabling models to update info. Fine-tuning can help keep your AI systems current with the latest information specific to your field or company, which is crucial.
Those are definitely valuable applications. But you mentioned cost earlier. Let's revisit that.
Right. It's important to be realistic. Generally, fine-tuning requires more money than some alternatives, like maybe just using RAG or prompt engineering alone.
Right.
That's due to the data prep, the compute resources, the expertise needed.
But there is a nuance there.
Yes. Specifically, instruction-based fine-tuning is cheaper and typically requires less data than continued pre-training. Because you're teaching specific input-output pairs, it can be less data-intensive and computationally heavy than trying to make the model absorb an entire new domain's worth of knowledge.
Okay, so instruction tuning is a bit more accessible, potentially.
It can be, but either way, you really need someone who knows what they're doing. You need an experienced ML engineer to handle the whole process, prep the data, tune the model parameters correctly, and then rigorously evaluate its performance to make sure it actually works well and reliably.
So definitely a strategic investment. Powerful, precise, but requires planning and expertise. It's not a shortcut, but a path to deeper integration.
That sums it up well. High precision often comes with higher requirements.
Now, you've touched on how fine-tuning relates to other techniques like RAG. Where does it fit in the bigger picture of AI concepts? Our sources link it to transfer learning. Can you unpack that connection?
Absolutely. Fine-tuning isn't some completely separate idea. It's very much part of a broader concept called transfer learning. At its heart, transfer learning is about how you reuse a pre-trained model to a new task.
Reusing knowledge, basically.
Exactly. Instead of training a model from scratch for every single new problem, which would take immense data and time, you take a model that's already learned a lot about the world, like these big foundation models, Cloud D3 or Bard in GPT, and you adapt that existing knowledge to your new task. Maybe you need a model to recognize specific kinds of cracks in infrastructure images, something very niche. Transfer learning lets you leverage a powerful general vision model and adapt it, rather than starting from zero.
Okay, so transfer learning is the general principle of applying old knowledge to new problems. Where does fine-tuning fit?
Fine-tuning is a specific kind of transfer learning. It's one of the main methods you use to achieve transfer learning, specifically by adjusting those internal weights of the pre-trained model based on your new task's data.
So transfer learning is the goal, and fine-tuning is a key technique to get there.
Precisely. It's often the most effective way to really embed that new task knowledge deeply into the model. And it gets even more interesting. You can actually use transfer learning by using output from one model to enhance another.
How does that work? Layering models.
Sort of. Imagine using a big, powerful language model to generate lots of synthetic training examples for your specific task, or maybe to automatically label some of your data. Then you use that generated or labeled data to fine-tune a smaller, more efficient model specifically for your application. It's like models helping train other models.
Wow. That's like a master craftsman creating specialized tools for an apprentice who then uses those tools to become even better at a specific job. It's leveraging expertise across the board.
It's a powerful way to build sophisticated, layered AI systems.
So we've covered a lot of ground today. We've dug into what fine-tuning is adapting these huge pre-trained models with our own data, changing their core weights. We looked at the different ways to do it, like instruction-based tuning versus continued pre-training for domain adaptation. We talked about the practicalities, the data formats, the resource costs, like provision throughput, needing ML expertise, and how it all fits under the umbrella of transfer learning. It really seems like this is about taking general AI power and honing it into a precision tool for very specific needs.
It really is. What's so exciting is how these techniques let us tailor AI to almost any specific challenge or domain. It's moving past this idea of just one giant AI brain towards creating countless specialized experts. It makes these incredibly powerful technologies feel more accessible, more customizable, truly ours in a way, from general intelligence to hyper-specific, useful expertise. And here's something to think about. If continued pre-training lets models gain expertise even from unlabeled data in a niche field, and instruction-based tuning is getting cheaper and needs less data, how might this change things for smaller companies or even individual researchers? Could this dramatically lower the barrier for creating highly specialized AI agents customized for very unique problems? Are we heading towards a democratization of truly tailored AI?
That's a fascinating thought. Democratizing specialized intelligence, definitely something to chew on as we see these models become more and more adaptable. Thanks for joining us on this deep dive into fine-tuning. We hope it's given you a clearer picture of how AI gets customized for real-world impact.